Hello, this is the Group 5 presentation of the Informatics Logic Assignment Session 7. And for a start, with me, MAMBUNA BOJANG, I will take you through the inference methods. So first of all, what do we mean by inference method? An inference is a conclusion drawn based on existing hypothesis, meaning an inference is used to test the truth value of a proposition or to generate new propositions from known propositions. Yeah, and there are 5 different types of inference methods, and they are modus ponens, modus tollens, the syllogism hypothesis, the disjunctive addition, and the conjunctive simplification. So the first one is the one I'm going to be taking you through, and it is the modus ponens. The modus ponens gives a premise. If you are given a premise in the form of a conditional statement, that is, if A, then B, and the premise A as an affirmation of the antecedent, then the conclusion is B. Meaning, if you have if A then B, and A has been confirmed to be true, then that means B is also confirmed to be true. Here we have an example saying, if I am a bird, then I can fly. That's what premise A says. Then premise B says, I am a bird. Then the conclusion is definitely going to be, I can fly. This is a perfect example of the modus ponens.
Modus tollens. Given the premise of a conditional statement A, B, and the premise negation B as a refutation of the consequence, the conclusion is negation A. Modus tollens is a valid form of argument because it follows the correct rules of logic. The logic rules underlying modus tollens are as follows. If P then Q, Q is not true, equal P is not true. In the case of the above argument, the first premise is a conditional statement, i.e., if I am hungry, then I will eat. The second premise is a statement that denies the effect of the conditional statement, i.e., I'm not hungry. Using the above rules of logic, we can conclude that the first premise is also not true. The reason is that if the first premise is true, then the corollary, i.e., I will eat, must also be true. However, since the second premise is true, i.e., I'm not hungry, then the corollary of the first premise cannot be true. Therefore, the first premise is also not true. In other words, the above argument is valid because the second premise denies the corollary of the first premise. If the consequence of the first premise is false, then the first premise must also be false. For example, premise 1, if I am hungry, then I will eat. Premise 2, I am not hungry. Conclusion, therefore, I will not eat.
Okay, I'm Nabila. In here, I wanna explain about syllogism hypothesis. Syllogism hypothesis is transitive nature of implication. If P, so Q, and Q, so R are both true, then P, so R is also true. Example, in this there's premise 1. If I pass the exam, then I will be admitted to the university. In here, if I pass the exam is P, so then I will be admitted to the university is Q. Premise 2, I pass the exam. I pass Q to R, so R. And conclusion, I will be admitted to the university. I will be admitted is P, to the university is R.
Disjunctive addition. Based on the fact that a statement can be generalized with the conjunction or. The reason is because the or conjunction refers to true if one of its components is true. This rule can be expressed symbolically as follows. P equals P or Q, where P and Q are propositions. In other words, if we know that P is true, then we can also conclude that P or Q is true. This is because the disjunction or only requires that the proposition be true for the other disjunction to be true. Therefore, if we know that P is true, then the disjunction P or Q must also be true. For example, ALDILA likes to sing is correct. The sentence will become true if another sentence is added with a or conjunction. So the sentence ALDILA likes to sing or dance is still true, regardless of whether ALDILA likes to sing or not. Disjunctive addition is a useful rule of inference because it allows us to acknowledge statements by adding additional possibilities. This can be helpful in proofs and arguments, where it can be used to show that conclusion is true under a wide range of conditions. In the example above, we were able to use disjunctive addition to show that the statement ALDILA likes to sing or dance is true even though we only had information about ALDILA's liking to sing. This is because disjunctive additions allow us to add possibilities, and in this case, we added the possibility that ALDILA likes to dance. Conjunctive simplification. If several sentences are connected by a connector and the sentence can be taken on of them in particular, the narrowing of this sentence is the opposite of the addition of the disjunctive, which is the expansion of the sentence. Conjunction simplification is a valid rule of inference in logics that states that if conjunction is true, then either of its conjunction must also be true. This rule can be expressed symbolically as follows: P and Q equals P, where P and Q are propositions. In other words, if we know that both P and Q are true, then we can also conclude that P is true. This is because the conjunction and requires that both propositions be true for the entire conjunction to be true. Therefore, if we know that the conjunction is true, then we can be sure that each of its individual conjunctions must also be true. For example, NABILA is found in Indonesian and English. The premise is a conjunction because it's connected to proposition. NABILA is found in Indonesian and NABILA is found in English. Using the words and. Using conjunction simplification, we can infer the following conclusion: NABILA is found in English. This conclusion is valid because we know that the premise is true and premise implies that NABILA is found in English. Conjunction simplification is a useful rule of inference because it allows us to simplify complex conjunction in simpler proposition. This can be helpful in proof and arguments where it can be used to reduce the number of steps required to reach a conclusion. Thank you.